Rex will translate along the starboard side of the space station, along the lab, and along the Node 2 module, where he'll pause briefly to open up a flap at the berthing port where Columbus will be attached. This will allow for camera views to be available to the robotic operators. He'll then continue down into the payload bay and set up for his work there, installing a few bags and pre-positioning some hardware so that he has a nice staging area to work from. EV2 will also be translating to the payload bay, but he will perform this translation along the port side of the space station, again along the lab and Node 2. He will stop to pick up a foot restraint, which he will later install in the arm off of the station's arm so that he can use that as a work platform for his work. One of the first tasks that EV1 will be doing when he's at the work site is to demate a power cable from the Columbus module that powers the heaters during ascent. That cable will be disconnected and stowed on a carrier panel on the side of the orbiter. Meanwhile, EV2 will be working with the arm operator to bring the arm down into position to install a foot restraint, and then he'll ingress that foot restraint, and GCA, or ground control, assists the arm operator into position to remove a grapple fixture from the sidewall of the orbiter for later installation onto Columbus. While that work is in play, EV1 will begin some preparatory tasks on the Columbus module to get it ready to receive the new grapple fixture. We'll start by removing one of two shields that will be required to be removed. The first one shown there highlighted. And then momentarily, EV2 will come along with the grapple fixture and attach it with 4 expandable diameter fasteners. Now, the reason we have to install the grapple fixture is because of clearance concerns with the OBSS, or boom, that was launched in the payload bay. So once that's installed, the 2 crew members will work together to then remove a second shield so that we can attach some electrical cables underneath. This video here is taken from our NBL, or Neutral Buoyancy Laboratory facility, where we do most of our training. You can see the panel's rather large. They work together to stow that out of the way, and then they attach the 2 electrical connectors that provide power from the arm into the Columbus module to power the heaters during the transition to the payload bay. The 2 shields will then be reinstalled, and the crew members will clean up from that work site. The last task that has to be performed to prepare the Columbus module for berthing is the removal of 8 CBM, or Common Berthing Mechanism, seal covers that protect the seals from debris during launch. Those covers are shown here in the video. They're basically crescent-shaped hard shells that we'll stow in 2 trash bags and take back to the airlock. Meanwhile, EV2 will be coming off the arm and removing the foot restraint so the arm can later grapple the Columbus module. Both crew members will translate back to the airlock to change out some hardware and then continue on to the P1 truss area, where they will set up some hardware on the CETA cart, or translation cart, in preparation for stowing a nitrogen tank on the following EVA. We will be installing 2 clamps there, and then we'll be releasing a few bolts on the nitrogen tank assembly and demating the electrical connectors. EV2 will translate to the back side of the truss segment to open up a shroud and demate 2 flex lines that connect the nitrogen tank to the ammonia system for pressurization. And then, if time is still available at the end of the EVA, we will be transferring a new piece of hardware out to the outside of station. It's a temporary stowage device that is essentially a bracket that we can attach to large components to aid in stowing that hardware during change-out operations. For EVA2, again, we translate along the station and into the payload bay to start our operations. This next video kind of shows you a bird's eye view of what the translation path will look like for in this case, EV1. Translates underneath the space station, down along the laboratory module, across Node 2, where he passes the arm, then down into the payload bay, and he meets up with EV2 in that location there. Again, we'll start out by being in the arm, and we'll remove the nitrogen tank from the underside of the carrier. The removal of the tank requires us to first open up an MLI cover, or a thermal flap, if you will, from around the nitrogen tank, and then we'll release 4 bolts that attach it to structure. We can then slide the tank off of a rail system that normally secures it to the truss or to the hardware in the payload bay. The nitrogen tank weighs around 550 pounds, and it is roughly the size of a small refrigerator. As that work's finishing up, the EV1 will ride the arm to the truss segment. EV2 will spend a little bit of time installing thermal covers over the exposed trunnion pins on the Columbus module, and then he will translate out again to the P1 truss segment to get into position to help EV1 stow that first new nitrogen tank onto the CETA cart. Because it's so large, it's kind of a 2-person operation to secure that. EV1 will then work with the arm operator to get into position to pick up the empty nitrogen tank out of the truss, and EV2 will get into position again to help stow that onto the CETA cart. Then they will make a maneuver up to the new nitrogen tank, pick it up, and bring the arm over into position for the installation. EV1 will secure the bolts and the electrical connectors for the tank, and EV2 will translate over to the backside to again hook up the flex lines that run to the ammonia tank assembly. They'll then work together to release the empty tank and begin its maneuver back to the payload bay for its return. During this arm maneuver, EV2 will clean up the hardware that we temporarily installed on the CETA cart, take it back to the airlock, and then he'll eventually meet up again with EV1 back in the payload bay where the tank will be installed. That'll complete our work off of the arm for that EVA, so we'll reconfigure the foot restraint, and then we'll translate up back onto the space station and work with the 2 power cables that are part of the station to shuttle power transfer system. There are 2 cables that we'll be rerouting. One will run along the upper surface of the Node 2 module and hook up to the pressurized mating adapter. The other cable runs along the port, or the starboard and underside of the Columbus module, which you'll see as we fly around here. And this will be the first EVA that we actually get to work on space station with the Columbus module installed. So it'll be an interesting perspective for the crew to work with that piece of hardware. And that'll complete our EVA 2 tasks. As we get into EVA 3, again, we will egress from the airlock and head right down to the payload bay. We will get onto the station's arm again and get into position for the removal of the solar payload. Solar is a sun observation experiment. They'll work together to release that, and then the arm will fly. In this case, it's EV3. We'll be working off the arm. Fly him into position for the installation on the uppermost platform on the Columbus module. The 2 crew members will work together to provide that fine alignment of the attachment interfaces and drive a single bolt for the attachment. The arm will then reposition Stan down underneath the Columbus module, where he will install another thermal cover over the last remaining pin on Columbus, this being the keel pin. Once that's complete, the arm will then position Stan over to the stowage platform where the CMG, or the counter moment gyro, is installed. They'll work together to open up a thermal cover on that piece of hardware and finally make some fine adjustments to secure it for return. And then they'll release the gyroscope from the pallet and begin the translation back to the payload bay. This video here shows what it looks like to have a guy on the end of the arm holding the CMG and being transferred by the RMS, or the SSRMS. That transfer happened back on 13A.1 before they did the initial